Now pay attention to a new character we're going to introduce you to, Pascal Petit. Of all the people in the Wharram community we've met so far, this one is quite special. When Remy broke his neck, Pascal was one of the first people I called. For the next big stage of drawing the lines, we could not have done it without Pascal. Drawing the lines, or lofting, is the process of reproducing the plans onto a sheet of drawing plywood that will become a working template for the whole boat build. The Narai Mark IV is a direct descendant of James Wharram's Rongo, on which he, Ruth and Jutta made their pioneering voyage across the North Atlantic in 1959. Now considered a classic design, our Narai IV plans are quite vintage. Having built a 1/10th scale model of one hull over the winter as a family, we had noted some corrections we'd like to make on the full-scale build. Now, under the guidance of Pascal, with over 60 boat builds to his name, we were ready to implement improvements. On two 3-metre sheets of 5mm drawing plywood, we began lofting from the midships section at half a scale of our 12-metre boat. This would allow finer accuracy to make adjustments. Okay. C'est bon? Pascal was patient in teaching us the importance of paying particular attention to detail during this crucial phase of boat building. Mistakes in lofting can cause major headaches down the track. And don't worry, we made mistakes and we ended up lofting over several days.
On va se caler sur celui-là. Je vais mettre de chaque côté et on va regarder ce que ça donne. Ouais, donc là, tu vois, c'est continu. Le gars, c'est continu.
Just got back to the boatyard today. Remy and I are here together.
Hello.
And we are going to continue on with drawing the lines. We just have a little bit to finish. Last time we drew the plan view, the bird's eye view, and now we're going to be drawing the section view, which is done at full scale. The other two views we did at half scale. First of all, how's your injury?
Well, it's actually getting closer to the end. I don't feel any pain. And since I have to be patient, sweat, stink a bit more in it, and it should all go back to normal, I think, with full capacity, I will say January to March 2026. So until then I have to be really careful and take the time to be diligent, yeah.
What tools have we added to our toolkit here in the past week?
Well, as we are in the drawing, mostly drawing stuff. It's that, how you call that in English?
I have no idea.
Well, it's a compass, right?
Kind of like
Yeah.
a compass, yeah.
And so instead of, measure, have an approximation, go back to do the measurement again, you multiply the approximation and then the mistake. With that, we're going to be able to take exactly the width and go to the drawing of the section and make it exactly.
With the lines drawn, we were ready to switch our focus back to materials. Over the past year, I'd been heavily researching the legacies of materials used in Wharram Catamaran builds. These minimalist boats are today commonly built with plywood, hardwood timber, epoxy resin, and a small volume of fiberglass sheathing around the exterior. Electric, but I don't know how to use it. Wanting a lower impact boat, whilst at the same time making sure we stuck within our budget constraints, we set ourselves somewhat flexible parameters. For the plywood, we chose Tebopan Elite, a French-grown and produced maritime pine. On the technical data sheet, and our advisors approve. It looks fantastic and a really good option for European boat builders. Pascal has requested that I cut 3 small samples of the maritime pine plywood, the Tebo Elite plywood that we're using on the boat build, to take down to his boatyard in Lorient tomorrow so that we can do some further epoxy testing. He's been doing some tests with the 100% change climate bio-epoxy that we have a sample of, and we need to test it on the plywood. So that's what I'm going to just cut up right now. I'm not particularly good at cutting straight, but I'm going to do my best. I have shaky hands, but this is what we have today, so I'm going to do my best with it. Oh, maybe we don't have any power. For some reason, the power is not working. We have the lights on, but the power box just there is not working at all, and I've checked all the power mains and everything seems to be normal. No one at Capso is here right now, so I can't ask for any help, and I really need to get these samples done. So it looks like I'm going to be cutting them by hand with a handsaw. At the moment, I'm rereading James Wharram's book, Two Girls, Two Catamarans, and he built his first boat, Tangaroa, with a handsaw. So, wow. And I'm not going to cut the other way. I'm going to hopefully do that with Pascal tomorrow in his work shed. Pascal applied our sample of Change Climate 100% bio-epoxy to the plywood, returning to our boatyard so we could conduct breaking point testing together.
You can compare 180 grit and peel ply. A sample of filler for finishing at the outside. This is rough, just troweled and sanded, rough sanded, ready for undercoat of paint. Outside of the hull, of the planking, there is one first layer of 400 grams resin, and then the glass close, 500 grams close and resin and peel ply pulled.
What do you think of the bio-epoxy?
The bio-epoxy, let me tell you, it's one of the best I used for the user first. Secondly, for several qualities, wetting power, transparency, consumption, but there is one big drawback. The initial tack is bad, very low, and it must be improved. Either the maker of the resin make it more tacky or more thixotropic. In the boat you have many sloped or vertical surfaces to glass or to impregnate with the resin. And if you have no tack or very low tack, the glass clothes will not hold. Even when wet, it will be difficult. But for the rest of the qualities, quite good. This one is the same sample, same composition of sample. It's a finished piece of planking, and it's screwed on two supports to make a puncture test. What is interesting now is to see how it breaks. It will break with difficulty because it's very strong already. The gap between the two supports is the maximum gap 300 millimeters. Okay, it's the widest gap you can have in the boats, so it's a worst case for puncture and breaking.
Okay.
One. What can you see? Here and here. The shock was here, and it delaminates slightly here, following a glass fiber. This glass cloth is not woven, it's stitched. It's 2 layers of 0 degree and 90 degree fiber. Again, you see the delaminating, the hit was here. You see the delaminating of the fiber over there, and so on. You see, it's worse, but wow. The boat still floats. Now let's look behind.
Oh la la!
The plywood broke in tension. There is no fiber here, only the resin, 500 grams of resin per square meter. The plywood, the first ply, breaks in tension. You see the fibers of the second layers, so the glue line didn't fail. It's a wood. We continue. Interesting, in the edge there is a fracture, so clearly the skins hold. It's a plywood that fracture inside. We continue until it breaks. First break was the surface layer of veneer, this, and then it breaks in the middle, and lastly it delaminates. It's the last. First you see the small delaminations on the shocks and on the fiber, but now see on the edge the cloth is peeling, but already the plywood is broken, so it means the skin will be still watertight after the plywood breaks. That's it. It's your boat. Now repair it. This is 2 samples of fillets. This is low density fillets, and this high density. This is aluminum microballoons, and this is cotton fiber. Okay, I make a mark at 5 centimeters from the face. This is 5 times the thickness of the plywood. I will hit after this, not here. Nice. It was here. The sample was glued on the edge first, and this broke in compression. The fillet, the under fillet, broke in compression, and the one in tension didn't break. It's still full.
Is that good?
It's okay. It's a criterion. And the second one with high density. You must hit on the right place. Okay. Voilà. You can see the movement I have to say also the supports have 2 coats of resin already before making the fillets. In this case, it's a small fillet but high density. It broke in compression and it delaminates in tension. And now the real thing, it's a combination of high density fillets and glass fiber on both sides. This is even stronger. You see why? The plywood failed in the thickness of the plywood. It means this is not breakable with this kind of plywood. And underneath, you see the compression of the glass fiber. The fillet is broken, but the glass fiber itself is not broken. Voilà. So this kind of joint is useful for bulkheads to hull, for any structural, for making a deck cabin, for example. You can assemble like this. All plywood to plywood junctions can be made with this high density fillet. And one layer is double bias, 400 grams, either side.
Incroyable.
Voilà. This low density fillet is weaker than the plywood. The position was this. It broke in compression here. It doesn't peel from the plywood, so the breakable part is the fillet itself. Yeah. But this is good for accommodations, light things, not structural
part.
If you want structure, you must add glass fiber.
So that was the goal of the tree test.
Even with the high density fillets.
It doesn't work.
It's not enough. You should have, if you want only a fillet, you should have a big high density fillet. But it's weight and consumption of resin. The best combination is small fillets, high density, and glass fiber.
That's for structural, but
yes.
For inside and bed and armoire and everything?
This, or better, this low density.
Okay.
For accommodation, low density fillets only, structure, high density fillets, and glass fiber.
Okay.
It's the lightest, cheapest combination, and least work. Least man hours to do it.
Long-lasting?
It's long-lasting because it's stronger than the plywood itself, simply.
How do we feel about the plywood?
The plywood is nice about mechanical properties, and it has also a special feature. It will drink quite a quantity of epoxy in the first ply. This is good.
Makes it stronger.
It's a little heavier, but it's absolutely guaranteed. The plies are equal. The quality of the faces are good. It's A or double A, something like this. The weight is okay. It's on par with exotic woods, a little less. It's 0.6 density. Mahogany plywood would be 0.65, something like this. It's a little lower, and it's good. It's stiff and cheap.
Feeling good, Captain?
Yeah.
Co-Captain.
Captain.
Confident with our plywood choice and bio-epoxy tests, Pascal and I went on a 2-hour road trip to sight some Movingui legacy hardwood that was in stock with the 2 generations carpenter family that we would use for the hardwood structural elements of the boat. This would also enable us to stick within our desired ethos of not importing any exotic hardwood from Africa. It was like Christmas when our friend Frank and his family delivered the wood. We were now ready to go.
Avec le 4x4 là.
That's all for today, folks. In the next episode, I take a little trip to Port Townsend in the USA for the Wooden Boat Festival. And when I come back, we dive straight into cutting these big hardwood planks of Movingui. Hey everyone, thanks so much for watching the videos as always. I just wanted to pop in here at the end to let you know that we would be so grateful if you would consider becoming a member of the Floating Stories Lab. I'll pop the membership links in the comment section below, and for 20, 50 or 150 euros per year, you can really help the project move forward and become part of our inner circle. Thanks and see you next episode.